Dr. Kaku, I am very excited to talk about this. The discovery of an Earth-like planet a mere 4.2 million light years away. How big of a deal is this?
This is a game changer because astronomers have hit the jackpot. This is their dream come true. A new chapter in astronomy has opened up. This planet is 4.25 light years. That's a hop, skip, and a jump. Right. And Stephen Hawking, my colleague, has already stated that in 20 years time, we'll send the first probes to the nearby stars. A new chapter in astronomy. Instead of trying to explore the solar system, now we're actually thinking about going to the next solar system in outer space.
Scientists looking for life on other planets like to talk about the Goldilocks zone, not too hot, not too cold, but just right. And now NASA's found a planet that's right in that zone.
If it had an atmosphere like Earth, there'd be 70 degrees there right now.
70 degrees, and that's what makes scientists believe that the potential is there for life.
The potential is there, and it's very exciting because in the catalogs of planets that we now have, this is the first time we take something like 300,000 years to get there.
I love an astrophysicist.
Back of the envelope calculations.
That was live, an astrophysicist's mind doing all those numbers.
Proxima B, a captivating exoplanet located just over 4 light-years from Earth, has emerged as a focal point in our quest to uncover the mysteries of extraterrestrial life. Orbiting the red dwarf star Proxima Centauri, this intriguing rocky planet resides within its star's habitable zone, making it one of our most promising candidates for finding life beyond our own world. The allure of Proxima B lies not only in its proximity, but also in the tantalizing possibilities it presents for understanding the conditions that could support life. Proxima B, a planet orbiting the red dwarf star Proxima Centauri, lies just over 4 light-years away from Earth. This seemingly modest distance in astronomical terms has made it one of the most discussed and debated planets in the search for extraterrestrial life. Discovered in 2016, Proxima B immediately captivated the scientific community, as it resides within the habitable zone of its host star, where liquid water could theoretically exist on its surface. At first glance, Proxima B appears to share some similarities with Earth. It is rocky, slightly larger than our planet, and occupies a position where conditions might support life. Yet the closer we examine this exoplanet, the clearer it becomes that Proxima B is a world filled with extremes, paradoxes, and mysteries that challenge our understanding of habitability and life itself. Unlike Earth, Proxima B orbits its star at an incredibly close distance. This proximity results in a year lasting just 11 Earth days. While this might suggest an environment rich with warmth, the reality is far more complex. Proxima Centauri, a red dwarf star, emits only a fraction of the light and heat of our Sun, and its intense stellar activity creates a series of hazards that make Proxima B an unpredictable and volatile world. One of the most intriguing and challenging features of Proxima B is that it is tidally locked. This means that one side of the planet is in perpetual daylight, constantly facing the star, while the opposite side is trapped in endless darkness. This peculiar configuration results in 2 extreme environments, a blisteringly hot day side and a frigidly cold night side. The stark contrast between these 2 sides creates a delicate region in between, often referred to as the twilight zone. In this narrow band, temperatures might be mild enough to allow liquid water to exist, making it the most promising area for habitability. However, such a region is not without its complications. The intense temperature gradients between the day and night sides likely generate powerful winds and turbulent weather patterns that could make life challenging, if not impossible. The twilight zone is also vulnerable to the effects of Proxima Centauri's frequent stellar flares. These massive eruptions of energy release high doses of radiation, potentially stripping away a planet's atmosphere or bombarding its surface with harmful particles. For life to thrive in such conditions, it would need to evolve extraordinary resilience or find refuge underground, away from the unrelenting dangers of space. One of the most puzzling discoveries regarding Proxima B involves unusual light emissions detected by the James Webb Space Telescope. These enigmatic signals, originating from the planet's dark side, have sparked a wave of speculation and scientific curiosity. Could these emissions be caused by natural phenomena such as volcanic activity, auroras, or thermal radiation? Or, as some researchers cautiously suggest, could they be evidence of advanced alien technology? The regularity and intensity of the emissions are unlike anything seen on Earth or other studied planets, prompting some to theorize that these lights might represent a form of artificial communication or energy use. If this is the case, it would be a groundbreaking discovery that reshapes our understanding of life in the universe. However, such theories remain speculative as scientists work to analyze the data further. The possibility of alien life is tantalizing, but it's equally important to consider natural explanations, such as magnetic interactions or geological activity, that could produce similar results. Proxima B's environment is a reminder of the harsh realities that many exoplanets face. The combination of tidal locking, extreme weather, and constant exposure to radiation creates an almost apocalyptic setting. Despite its location in the habitable zone, these conditions make Proxima B a planet of contradictions, where the potential for life is constantly at odds with the forces of destruction. Red dwarf stars like Proxima Centauri are notorious for their unpredictability. While they are smaller and cooler than our Sun, they are far more active, releasing powerful flares that can wreak havoc on nearby planets. For Proxima B, this means that any atmosphere it might possess could be gradually stripped away, leaving it vulnerable to space radiation and harsh surface conditions. Yet red dwarf stars are also the most common type of star in the galaxy, accounting for about 70% of all stars. This makes them crucial to the search for extraterrestrial life. Despite their challenges, the abundance of red dwarfs and the number of planets orbiting them provide countless opportunities to discover new worlds like Proxima B. The existence of an atmosphere on Proxima B is one of the most critical questions in determining its habitability. Recent observations from the James Webb Space Telescope have hinted at the possibility of a thin and unstable atmosphere. Traces of carbon dioxide and water vapor have been detected, suggesting that the planet might have retained some of the essential components for life. However, the atmospheric pressure and composition remain unknown. If Proxima B has a strong enough magnetic field, it could protect its atmosphere from being stripped away by solar winds. Without such protection, any atmosphere would likely be short-lived, reducing the chances of liquid water and life on the planet's surface. While the twilight zone may offer the best conditions for habitability, it is far from an ideal environment. The region would experience constant winds as heat flows from the day side to the night side. These winds could create cyclones and storms, adding another layer of complexity to any potential ecosystem. Despite these challenges, Earth has shown us that life can adapt to extreme environments. From microbes thriving in boiling hot springs to organisms surviving in the deepest parts of the ocean, life has a remarkable ability to find a way. Could similar forms of life exist in the twilight zone of Proxima B? Another intriguing possibility is the presence of subsurface oceans on Proxima B. Beneath its radiation-battered surface, the planet might host vast reservoirs of liquid water, shielded from the hostile environment above. Geothermal activity could provide the necessary heat to sustain these hidden oceans, much like Earth's deep-sea hydrothermal vents, which are teeming with life despite the lack of sunlight. If Proxima B does have subsurface oceans, it would significantly increase its chances of supporting life. These underground environments would be protected from radiation and temperature extremes, creating a stable haven for microbial or even more complex life forms. The mysteries of Proxima B have reignited humanity's desire to explore the cosmos. While a journey to this distant world is far beyond our current capabilities, projects like Breakthrough Starshot aim to send miniature probes to the Proxima Centauri system within the next few decades. These tiny spacecraft, propelled by light sails, could provide valuable data about Proxima B's surface, atmosphere, and potential for life. In the longer term, The dream of crewed missions to Proxima B represents one of the greatest challenges in human history. Such an undertaking would require revolutionary advancements in space travel, energy production, and life support systems. Proxima B is a planet that embodies both hope and hostility. Its extremes challenge our understanding of what it means for a world to be habitable, while its mysteries push the boundaries of science and imagination. Each new discovery brings us closer to answering one of humanity's oldest questions: are we alone in the universe? As we continue to study Proxima B and other distant worlds, we are reminded of the uniqueness and fragility of our own planet. Earth remains the only known sanctuary for life, a fact that underscores the importance of protecting our home while daring to explore the vast unknowns of space.